Space is vast and honestly, just full of mystery. It stretches out in every direction, farther than our minds can truly grasp. Every time we look up, we're peering into a cosmic ocean that has fascinated humans for thousands of years. When we look up at the night sky, we see countless stars, so many that it's hard to even imagine. Each tiny point of light is a reminder of how small we are and how much there is left to discover. Many of these stars are actually suns in their own right, orbited by their own planets. Some of those planets might even have the right conditions for life, making the universe even more intriguing. But the stars we see are just the beginning. Beyond them, there are even more wonders waiting to be uncovered. They're grouped together in these huge collections called galaxies. Each galaxy contains billions, sometimes even trillions of stars and planets. Galaxies are like islands of stars, separated by, truly vast distances. The space between them is so immense, it's almost impossible to comprehend. For a long time, we thought these galaxies were scattered randomly throughout space. It seemed like there was no order, just chaos. They just seemed to drift alone in the darkness, isolated and far apart from one another. But turns out, we were wrong. The universe is far more connected than we ever imagined. There's actually a hidden structure that connects these islands of light. Invisible threads stretch across the cosmos, linking galaxies together. There is a pattern to the universe, a kind of grand design. It's not random at all, but beautifully organized on the largest scales. Imagine a spider's web, with its delicate threads connecting everything together. The universe's structure is surprisingly similar, but made of galaxies and dark matter instead of silk. The universe has a similar structure, but on a much, much larger scale. These cosmic filaments stretch for hundreds of millions of light years, shaping the very fabric of space. It's called the cosmic web. This is the universe's hidden architecture, a breathtaking network that connects everything, reminding us that even in the vastness of space, nothing is truly alone. The cosmic web is this vast, almost unfathomable network of filaments and clusters that stretches across the entire universe. It's not just a random scattering of galaxies. There's a hidden order, a structure that connects everything on the grandest scales imaginable. These filaments reach across truly unimaginable distances, linking galaxies and galaxy clusters together like beads strung along invisible threads. The scale is so immense that even light, traveling at its incredible speed, would take millions of years to cross from one end of a filament to another. Picture a giant cosmic net, woven with strands of galaxies, each one caught in the intricate weave of this universal tapestry. It's a structure so vast and complex that it's almost beyond human comprehension. But these filaments aren't made of anything solid, like the threads of a spider's web. Instead, they're composed of dark matter and gas, substances that are mostly invisible to us, yet make up the majority of the universe's mass. Dark matter, in particular, is a mysterious ingredient. We can't see it directly with our telescopes, but we know it's there because of the way its gravity shapes the movement of galaxies and bends light from distant objects. It acts as a kind of cosmic glue, binding galaxies and clusters together and giving the universe its large-scale structure. The cosmic web is actually incredibly difficult to observe directly. For decades, it remained hidden, just out of reach. Only recently, with advances in technology and deep space surveys, have astronomers begun to map out its intricate structure. Using powerful telescopes like the Hubble and the Very Large Telescope, scientists peer deep into the cosmos, observing distant galaxies and quasars to gather clues about the web's existence. By carefully studying how these objects are distributed across space, astronomers can trace the outlines of the cosmic web, revealing the hidden framework that underpins the universe. This discovery has, without exaggeration, completely revolutionized our understanding of the cosmos. It's changed the way we think about the universe's formation, evolution, and the forces that shape it. We now know that galaxies aren't just isolated islands floating in space. They're all part of a vast, intricate network of matter and energy connected across the universe by the invisible threads of the cosmic web. These filaments are like rivers of matter flowing through the universe. They channel gas and galaxies along their lengths, shaping how matter is spread out on the largest scales. Where these filaments intersect, we find these enormous clusters of galaxies. These clusters are like bustling cities in the cosmic web, just teeming with activity. The filaments themselves aren't uniform, though. They have areas of higher and lower density. This clumpiness is actually a result of the early universe. Tiny fluctuations in the early universe, just after the Big Bang, were amplified by gravity over time, leading to the formation of the cosmic web. These filaments are constantly evolving, always stretching and pulling, influenced by the gravity of the matter they contain. Galaxies move along these filaments, sometimes colliding and merging with one another. Gravity plays a crucial role in shaping the cosmic web. It draws matter together, creating the filaments and clusters that we observe. Imagine throwing a handful of marbles onto a trampoline. The marbles represent galaxies, and the trampoline represents the fabric of space-time. Just like the marbles create dips in the trampoline, galaxies warp space-time around them. This warping is what we experience as gravity. As galaxies move and interact, they create gravitational forces that pull matter together, forming the filaments and clusters of the cosmic web. The expansion of the universe also affects the cosmic web. As the universe expands, the filaments stretch and become thinner. However, gravity counteracts this expansion, pulling matter together and preventing the web from being completely pulled apart. Mapping the cosmic web is honestly a pretty challenging task. The filaments are so faint and difficult to detect directly. However, astronomers have developed some really ingenious methods to uncover its structure. One method is to observe distant quasars. Quasars are these extremely bright objects powered by supermassive black holes at the centers of galaxies. As light from a quasar travels towards us, it passes through the cosmic web. The gas in the filaments absorbs some of this light, leaving a faint imprint on the quasar's spectrum. By analyzing the light from many quasars, astronomers can create maps of the intervening gas clouds, revealing the structure of the cosmic web. They can also use gravitational lensing to map the distribution of dark matter. These maps are helping us to understand the large-scale structure of the universe and the role that the cosmic web plays in galaxy formation and evolution. The cosmic web acts as a network of highways for galaxies and gas. Galaxies are not static objects. They move along the filaments, drawn by the gravity of the matter within them. As galaxies travel along these filaments, they can interact with each other, and sometimes they even collide and merge. These mergers can trigger bursts of star formation, creating, honestly, some truly stunning displays of cosmic fireworks. The filaments also channel gas towards the centers of galaxy clusters, where it can fuel the growth of supermassive black holes. Understanding how matter flows along these cosmic highways is, well, absolutely crucial for understanding how galaxies form and evolve over time. The cosmic web is not only a testament to the power of gravity, but also a treasure trove of information about the early universe. The pattern of filaments and voids in the cosmic web actually reflects the tiny fluctuations in density that existed in the early universe, just after the Big Bang. These fluctuations, imprinted on the cosmic microwave background radiation, were amplified by gravity over billions of years, eventually leading to the formation of the cosmic web itself. Studying the properties of the cosmic web can help us learn about the conditions in the early universe. By analyzing the distribution of galaxies and the properties of the filaments, astronomers can test cosmological models and gain insights into the fundamental properties of the universe. The cosmic web is a reminder that we are part of a vast and interconnected universe. Our galaxy, the Milky Way, is actually located within one of the filaments of the cosmic web. We are connected to distant galaxies through this vast network of matter and energy. Understanding the cosmic web is honestly crucial for answering some of the biggest questions in astrophysics. How did the universe evolve from a smooth, homogeneous state to the clumpy, structured universe we see today? What is the nature of dark matter and dark energy, those mysterious substances that make up the majority of the universe's mass-energy budget? By studying the cosmic web, we can gain a deeper understanding of the universe's origins, its evolution, and our place within it. The discovery of the cosmic web has, without a doubt, revolutionized our understanding of the universe. For centuries, we imagined the cosmos as a collection of isolated galaxies, each drifting alone in the vastness of space. But now, we know that the universe is far more interconnected and dynamic than we ever dreamed. It shows us that galaxies are not isolated islands. They are part of a vast, interconnected web of matter and energy. These filaments, stretching across unimaginable distances, act as cosmic highways, channeling gas, dust, and even entire galaxies along their lengths. This web is the product of billions of years of cosmic evolution, shaped by the interplay of gravity, dark matter, and the expansion of the universe itself. Over time, these forces have sculpted the universe into a breathtaking tapestry, with dense nodes where galaxies cluster and vast voids where almost nothing exists. As we continue to explore the cosmos, the cosmic web will undoubtedly reveal even more of its secrets. Each new observation peels back another layer, helping us understand how galaxies form, evolve, and interact within this grand structure. New telescopes and technologies will allow us to map its structure in greater detail and study its properties with ever-increasing precision. Instruments like the James Webb Space Telescope and next-generation observatories are already pushing the boundaries of what we can see and measure. These discoveries will shed light on the fundamental laws of physics, the evolution of galaxies, and honestly, the ultimate fate of the universe. By studying the cosmic web, we gain insights into the mysterious dark matter and dark energy that make up most of the cosmos. The cosmic web is a reminder of the beauty and complexity of the universe we live in. Its intricate patterns inspire awe and wonder, challenging us to look deeper and ask bigger questions about our origins. It's a testament to the power of scientific inquiry and our insatiable curiosity to understand the cosmos and our place within it. Every discovery brings us closer to answering some of humanity's oldest questions. As we delve deeper into the mysteries of the cosmic web, we can expect to make even more profound discoveries that will reshape our understanding of the universe and our place within its grand design. The journey is just beginning, and the cosmic web continues to beckon us onward, inviting us to explore, to learn, and to marvel at the universe's endless wonders.